If you've spent any time in off-grid forums, you've heard the assumption. Lead acid is the budget chemistry. Lithium is the luxury tax. Golf cart batteries are cheap, LFP costs more. That's where almost everyone starts. Today, we're running the actual numbers, and the assumption doesn't survive contact with them. Here's the matchup. On one side, 8 Trojan T105 golf cart batteries, wired into a 48-volt bank. About as classic an off-grid lead-acid setup as exists. On the other, a single eco-worthy Cubics 100 Pro, a 48-volt, 100-amp-hour lithium iron phosphate rack battery. Same voltage class, same job. Let's compare them the right way. Not sticker price, actual usable power. The myth survives because most people compare rated capacity, the number printed on the battery, instead of usable capacity, which is what you actually get to use before you damage the battery. Those two numbers sit close together for lithium and very far apart for lead acid. And that gap is where the whole lead acid is cheaper assumption falls apart. Start with the numbers. 8 T105s at 225 amp hours gives you 10.8 kilowatt hours rated. The Cubics rack battery is rated at 5.12 kilowatt hours. On paper, lead acid looks like it's winning by more than double. But flooded lead acid needs to stay above roughly 50% state of charge to hit anything close to its rated cycle life. So that 10.8 kilowatt hour bank really gives you about 5.4 kilowatt hours you can actually use. EcoWorthy rates the Cubics for 6,000 cycles specifically at 80% depth of discharge. That puts it at about 4.1 kilowatt hours usable. Somewhat less usable capacity, not a wash, but look at what it costs to get there. A matched shipped set of 8 T105s runs close to $2,000. The single lithium unit is $949.99, less than half the price for about 3/4 of the usable capacity. But the upfront price isn't even the real story. Cycle life is. Trojan rates the T105 for about 1,200 cycles at 50% depth of discharge. The Cubics 100 Pro is rated for 6,000 cycles. That's 5 times the cycle life on the option that already came out cheaper per kilowatt hour. Cycled roughly once a day, that lead acid bank is due for replacement in 3 to 4 years. The lithium battery is still running strong a decade later. To match the same total years of service as one Cubics, you'd need to buy that lead acid bank 5 separate times, pushing $10,000 in batteries, versus $949.99 once. Now, weight and shipping. 8 T105 batteries come in at just under 500 pounds combined, and they take up real shelf space. This isn't something you tuck behind a cabinet. The Cubics rack battery weighs 105 pounds and fits in about 2 cubic feet. And here's the part almost nobody accounts for. Flooded lead acid is classified as a Class 8 corrosive hazardous material for shipping. It requires acid-proof packaging and hazard placarding, and a lot of retailers restrict it to local pickup or freight delivery rather than a box showing up at your door. The lithium battery ships like a heavy parcel. No acid, no placard, no special handling required. Safety follows the same pattern. Flooded lead acid needs ventilation, produces hydrogen gas while charging, and holds actual sulfuric acid that can spill or corrode terminals and hardware nearby. Lithium iron phosphate is the safest lithium chemistry available. Thermally stable, sealed, maintenance-free, and every reputable pack ships with a battery management system guarding against overcharge, over-discharge, and short circuit. None of this makes lead acid a bad battery. It's proven technology, and it's still a reasonable choice if you already own a bank or you're working with a hard budget ceiling. But lead acid is cheaper isn't the safe assumption it used to be. If you're sizing your own off-grid battery bank, don't copy somebody else's parts list. Run your own numbers. Head to beginnersolar.com/calc to size your build in a few minutes, or check the caption.